You're mastering the technique of completing the square. By the end of this session, you will be able to transform any quadratic into the vertex form, identify the key geometric properties of the resulting parabola, and apply this to range and solving equations. This is a fundamental pillar of the Cambridge 9709 Pure Mathematics 1 syllabus. It appears consistently in questions regarding coordinate geometry, transformations, and functions, specifically when you are asked to find the range or an inverse function. Mastery of this technique is essential for students aiming for an A or A star. To understand completing the square, we must first look at the algebraic derivation. We want to take the standard quadratic form, ax squared plus bx plus c, and transform it into the vertex form, a, open bracket, x minus h squared plus k. We begin by factoring out the coefficient a from the terms involving x. This gives us a multiplied by the quantity x squared plus b over a, x, then plus c outside. Now, we add and subtract the square of half the coefficient of x inside the parentheses. Since our coefficient is b over a, half of that is b over 2a. We square this to get b squared over 4a squared. By adding and then immediately subtracting this value, we haven't changed the expression's value, but we have created a perfect square. We group the first three terms into a perfect square trinomial, x plus b over 2a squared. Finally, we distribute the a to the subtracted term and combine it with c. This leaves us with the completed square form. Comparing this to our vertex form, we can see that h equals negative b over 2a and k equals c minus b squared over 4a. The vertex form gives us immediate geometric insight. In the form a, open bracket, x minus h squared plus k, the coordinates of the vertex are simply h, comma, k. The value of h represents a horizontal translation from the parent function y equals x squared. Notice that if the bracket is x minus 3, the graph moves 3 units to the right. The value of k represents the vertical translation. Crucially, k tells us the maximum or minimum value of the function, which is the key to finding the range in exam questions. Finally, the coefficient a determines the concavity. If a is positive, the parabola opens upwards, meaning the vertex is a minimum point. If a is negative, it opens downwards, making the vertex a maximum point. Let us apply this to a concrete problem. Here is an example. We want to express f of x equals 3x squared minus 12x plus 7 in vertex form. Then, we will state the vertex coordinates and the axis of symmetry. First, factor out 3 from the x terms. We leave the 7 outside for now. Next, look at the coefficient of x inside the brackets, which is negative 4. Half of negative 4 is negative 2, and squaring that gives us positive 4. We add and subtract 4 inside the bracket. The first 3 terms become x minus 2 squared. Then, we multiply negative 4 by the 3 outside the bracket to get negative 12. Adding negative 12 to 7 gives us negative 5. The vertex is at 2, negative 5. Since a is 3, which is positive, this is a minimum. The axis of symmetry is always the vertical line passing through the vertex. So here it is x equals 2. Graphically, we can see the translation from the standard parabola to our specific quadratic. First, we draw the axes. Next, the parent parabola. Then, the transformed vertex form. We mark the vertex. Finally, the axis of symmetry. Let's look at a typical Cambridge 9709 question. The function f is defined by f of x equals 4x squared plus 24x plus 11, for x is a real number. Part 1. Express 4x squared plus 24x plus 11 in the form a, open bracket, x plus b, close bracket, squared plus c. Part 2. State the range of f. First, we factor out the 4 from the x terms. Next, we take half of 6, which is 3, and square it to get 9. Inside the bracket, we add and subtract 9. Expanding the outer bracket gives 4 times negative 9, which is negative 36. Adding 11 gives negative 25. So A is 4, B is 3, and C is negative 25. To find the range, we look at our vertex, which is at negative 3, negative 25. Since the leading coefficient is positive 4, the graph is a U-shape, meaning negative 25 is the minimum value. Therefore, the range is f of x is greater than or equal to negative 25. In the exam, stating the range correctly often earns a specific mark, but you must look at the inequality sign carefully based on whether you have a maximum or a minimum. Let's discuss where students often lose marks in these A-level questions. The most frequent error is neglecting to multiply the subtracted constant by the factorized coefficient a. When you add and subtract a value inside the bracket, the subtracted term must be multiplied by the a outside before combining it with c. In our example, students often write negative 9 plus 11 instead of negative 36 plus 11. Remember that the formula is x minus h. If your bracket is x plus 3, the x-coordinate of your vertex is actually negative 3. A common mistake is stating the vertex as 3, negative 25, instead of negative 3, negative 25. For the range, if the parabola opens upwards, meaning a is positive, the range is greater than or equal to k. If you have a negative a, the vertex is a maximum and the range must be less than or equal to k. Students often default to greater than or equal to, regardless of the concavity. When the coefficient of x squared is negative, factorizing it out changes the sign of the x term. Be extremely careful when taking half of a negative coefficient. Let's look at some critical exam tips for your Pure Mathematics 1 paper. In Cambridge 9709 examinations, examiners look for clear evidence of your method. Even if your final answer is slightly off, you can gain method marks by showing the half the coefficient step. Always write down the value you are adding and subtracting. This signals to the examiner that you understand the process. A brilliant way to ensure accuracy is to quickly expand your finished vertex form in your head. If 3, open bracket, x minus 2, squared minus 5 doesn't expand back to your original expression, you know you have made a sign error or missed a multiplication. In A-level papers, the word hence is a massive clue. If a question asks you to complete the square and then says hence, state the range, you must use your completed square form. Using other methods like differentiation to find the vertex might result in 0 marks for that part, even if your answer is correct, because you didn't follow the instruction to use the previous result. When writing the range, ensure you use the correct notation. Use f of x or y, not x. Writing x is greater than or equal to negative 25 for a range will lose you the mark, as x refers to the domain. It is time to test your understanding. Please pause the video now and attempt these 3 questions. Question 1. Easy. Express x squared plus 8x plus 10 in the form open bracket x plus a, close bracket, squared, plus b. Question 2. Medium. Express 2x squared minus 12x plus 25 in the form a, open bracket, x minus h, close bracket, squared plus k. Hence, state the coordinates of the vertex. Question 3. Hard. The function g is defined by g of x equals negative 3x squared plus 6x plus 2 for all real x. Express g of x in completed square form and find the range of g. Take your time with these. Pay close attention to the signs and the multiplication of the constant outside the bracket. When you are ready, resume the video to see the full solutions. Let's go through the solutions to see how you performed. For the first solution, we start with x squared plus 8x plus 10. Half of 8 is 4. 4 squared is 16. Simplifying the trinomial gives x plus 4 squared minus 6. This gives us a equals 4 and b equals negative 6. In solution 2, we factor out the 2 from the x terms. Half of negative 6 is negative 3. Negative 3 squared is 9. Adding and subtracting inside the bracket gives 2 times x squared minus 6x plus 9 minus 9, all plus 25. This becomes 2 times the quantity x minus 3 squared minus 9 plus 25. Expanding the outer bracket, we get 2 times x minus 3 squared minus 18 plus 25, which simplifies to 2 times x minus 3 squared plus 7. The vertex is at 3, 7. Remember, the bracket is x minus 3. So h is positive 3. For solution 3, we factor out negative 3 from g of x. Note the sign change. 6 divided by negative 3 is negative 2 inside the bracket. Half of negative 2 is negative 1, and squaring it gives 1. We add and subtract 1 inside. This gives negative 3 times the quantity x minus 1 squared minus 1 plus 2. Expanding gives negative 3 times x minus 1 squared plus 3 plus 2, resulting in negative 3 times x minus 1 squared plus 5. Since a is negative 3, the parabola opens downwards. The vertex at 1, 5 is a maximum. Therefore, the range is g of x is less than or equal to 5. To summarize today's lesson, always factor out the leading coefficient first. Remember that the vertex coordinates depend on the sign inside the bracket, and the range depends on the value of a. To summarize our lesson on completing the square transforms a quadratic from standard form to vertex form. A, open bracket, x minus h, close bracket, squared, plus k, which is essential for identifying the graph's turning point. The coordinates of the vertex are h, k, and the axis of symmetry is always the vertical line x equals h. The value of k represents the maximum or minimum value. If a is positive, the range is f of x is greater than or equal to k. If a is negative, the range is f of x is less than or equal to k. Always remember to multiply the constant term inside the bracket by the leading coefficient a when simplifying, and pay close attention to the word hence in examination papers.